Users of VCV Rack, as well as users of Voltage Modular, know him because of the modules he has made under the brand name Vult. Dr. Leonardo Laguna Ruiz is the inventor of the programming language Vult, as well as the founder of the brand Vult, a bunch of software and hardware modular synthesizer modules. After more than 10 years developing scientific software, Leonardo decided to apply all his knowledge in electronics, mathematical modeling, and simulation to his favorite hobby, music technology. Currently, Leonardo still works developing the simulation core of Wolfram System Modeler and runs Vult with the help of his family and friends. Leonardo has developed 55 high-quality modules for VCV Rack and for Voltage Modular so far, all virtual analog and carefully modeled after real existing electrical circuits. And here he is, Dr. Leonardo Laguna Ruiz.
But at the same time, I always but at the same time, I always was interested in science, and I think I was, I don't remember, 10, 11 years old, something around that, when I started getting interested in electronics. And since then, I have been like studying electronics and going to electronic school.
Yeah.
But at some point, I wanted to do some to study music. But still, my electronic side was calling me. So when I had to make like the decision of going in the audio career path or the engineering, my parents told me, like, you know what, since I'm from Mexico, so the music industry is not I mean, even if it's big, is more complicated probably than in other places. My parents told me to finish an engineering degree, and that after that I could do whatever I wanted with the music.
I see.
But I continued with electronics, and then I got the opportunity to make a master and also a PhD, and I just get to that line, but always interested in music and music software, mathematical modeling, and also everything related to music technology.
And that is how you came to programming, to coding DSP software. Was that the reason? Your love for music and sound led you to work with DSPs? What about VCV Rack? Why VCV Rack?
It was because it was released at a very good time. I was like trying to do some filter models, and I was playing a lot with boards, and I was curious about Eurorack. And for some time, I had the idea of making a modular software, but I saw that VCV Rack was announced, and I immediately start trying to develop a plugin for it, and everything fit together very well. So I didn't have to bother creating the whole platform, just focusing. So I just focus on the modules and the ideas that I had, and since then I've been doing modules for VCV Rack, which is like the place where I like to experiment the most with my ideas.
Some of your modules are for free, and some of your modules are for a very, very low price. How do you decide what's for free and what are you selling?
It is usually the I decide based on the time that I spend developing them.
Mm-hmm.
If it is like a module that doesn't require me too much research or even spending money making a prototype, I put it for free. But some of the modules that I have developed, I invest a lot of time and also money to do it.
Sure.
Because it is because of my approach of making the modules. Because I always try to do a prototype, a physical prototype that I can use to take measurements and you know, like extract. I mean, it for me it's like a learning exercise. For example, if we think on one of the modules that I made more recently, I made a module that is based on it's an FM operator based on a Yamaha FM chip. And like in that case, I had to do. I created a prototype board. I spent a lot of time doing the code and just like buying the chips, finding the chips. And at the end, if I start like taking note how much I spent. That. And if it's a reasonable cost, I just set it for free. But other modules, for example, I did a collaboration with VCV Rack, which was a set of drums. And for those, I made, I don't remember how many boards for all the drums. Designed the boards, I built the circuits, I made the measurements, and it took me almost like 1 year.
Wow.
To develop all the drums. So those needed to be commercial.
I see, yes. So this means at first there is a kind of hardware, and then after that the software occurs.
Yes, that's usually my approach, because I want to understand, for example, in the case of the drums, what makes a good drum sound, or in this case, a good analog drum sound. And until I build it and I play with it, is when I have the idea how it should sound, or what are the good things that I like about the sound. And once I have that, I start making my digital versions. And those digital versions do not, at least for me, that's part of my approach. They don't need to exactly match, or they don't need to emulate a specific module or drum, but I want them to be as good as the analog, but also I try to make them better, according to my own taste.
I see. Let me try to repeat so that I can understand. So you use the hardware to get, let's say, the basic mechanisms, how it might work, and to get inspirations which sometimes lead to different sound qualities in the software. Is it right?
Yes. To give you other example, I was modeling a filter some months ago, and it was based on the 303 circuit. So I made my own circuit for it, and I started playing with it. And actually, I bought a module that was the same filter. But after playing with it, there were a few things that I thought that I don't like these things that much. And in my digital version, I can easily fix them because I can or improve them. For example, in this specific filter, when the resonance is completely zero, the filter adds distortion. So you need to add a little bit of resonance, and then the sound of the filter is not distorted. And I guess that for someone would say like, yeah, that's an essential feature.
Sure.
But at the same time, I didn't like that much that behavior, and I could easily fix it. Just not like reducing the gain when there was no resonance. And I did I didn't eliminate it completely, but I reduced that behavior. And I think that I got a very nice balance between the analog, the original analog circuit, and my digital model.
So I get a notion. So this is also the way, or let me put it like that. So you have your, let's say, hardware model. You have transferred bit more or less to software with the changes, and then you look at your hardware model and says, why not make even a real hardware module for Eurorack or something like that? Is that correct the way?
Yes, yes.
I see.
Most of the time I do it like that.
Yeah, and you produce your modules all alone, or do you give them away to a company to make them according to your circuits? The hardware modules now, of course, I think.
Yeah, I mean the modules that I design for selling, because I make a lot of modules, but they are just for me. They're quick prototypes, and all of them are assembled by myself. And in the case of the modules that I make for selling, it's a combination. Like some of the modules, one of the most popular. I actually have it here, like the freak filter.
Yeah.
This one, like the main board, like was made. I ordered it from a company.
Yeah. Okay.
And it's only like the main board, which has all of the difficult components to solder. But the rest I assembled it myself.
I see.
And for other modules, like the analog filters, I don't have them here. I build them by myself.
Wow, a lot of work.
Yeah, it's a lot of work, but also it's kind of a relaxing work because
I understand. Yeah. You may call me crazy, but when I'm completely exhausted after, for what reason ever, in the evening, I go and solder cables, patch cables.
Yeah, yes. Because you don't need to think that much.
Yes.
You just need to pay to have a little bit of attention. And I usually listen to music or an audiobook or something like that. And
Exactly. What role do the modules, or do your own modules play in your music when you make music?
So usually, I mean, most of the modules that I have made for VCV Rack or for Voltage Modular or Real are the result of some kind of experimentation that I'm doing. And I would say, I mean, the hardware I use them less because I have little space in my desk.
I see.
But so my rack is not that big, and most of the space I use while I'm testing modules, the modules that I sell.
Sure.
So my rack is basically utilitarian. I don't make too much music with my physical Eurorack because I'm always prototyping new things.
Yeah, sure.
But the VCV Rack versions, I use them a lot. So they are really fundamental.
Yeah, in nearly all of my voices, I use Basil. In some kinds of, I love this. I love the sounds I get out of this thing. Wonderful.
Yes, I like it a lot as well. For most of the when I'm developing new modules, I usually need an oscillator or something like Basil. For me, always makes a good sound.
Yeah, it's on one hand it's a quite warm sound, and the other hand it's strange if you want. It's really nice, really. Vult. What about Vult? What is it? It's okay. I know it's a programming language. It's your personal brand. Tell us a bit about it.
So yeah, Vult, it was initially the name that I gave to the programming language that I was developing.
Mm-hmm.
And later, when I needed to create a brand for it, I immediately picked Vult.
Mm-hmm.
So it just extended. So probably nowadays, Vult is more associated with the modules than with the language. So the language is my main tool, but it's not as is not. I mean, there are not too many users. So if I compare the number of users of the language to the number of users of the modules,
Sure.
it's very small.
Yeah, sure. Unfortunately, I will explain this. Unfortunately, later in our conversation. How did Vult occur? How did it come to life? How did you get the idea to make, let's say, a programming language for DSP on your own? There are a lot of computer languages outside. Why a new one?
Yes. So I mean, I've been using C and C++ for a long time to develop DSP things. And what happened, since I'm kind of curious and I'm testing new things, new platforms. For example, at some point I had like Teensy boards, and I wanted to make like a small synthesizer with them, Arduinos. I had also DSPs, like DSP chips, and each of those had like a different small things that are different when you code for them, but also like max, pure data, etc. And what I found was that when I wanted to make, when I had an idea, and let's say I pick pure data to make it. So I make my idea, and then you are kind of limited. No, I mean, you are not limited, but you are what you make in pure data, you can practically use only in that environment. Or if I do something in Max, it's the same.
Yeah.
And it was very often that I create something and I want to use it somewhere else. For example, I want to run it in an Arduino.
Yeah.
And then I had to redo the same algorithm. And then if I pick like a DSP chip, I was redoing it. So I decided that I started seeing the need for me to have like a more agnostic tool where I can like code these ideas, and if I write them in like a basic in a simplified language, it will be easy for me to generate whatever I wanted to do. For example, I make my simple DSP algorithm, and then I wanted to be able of generating C code or C++ code and running it in an Arduino, or generating that the same C++ code and grab it and use it in pure data. So that was my main intention, like having being able of writing a more portable code.
I see.
To do all my work. And also, since I was and actually I made different attempts to it. I made other languages with different ideas in order to achieve this, but at some point I decided to redo So the Vult language is like my 5th, 6th attempt. I don't know how many attempts until I decided to do that one. And I started developing, and after that, I mean, that was basically the one that stick, the one that I found most useful for me.
In what is it possible in an interview like this one, like ours right now, is it possible to describe the main differences between programming in Vult and programming in what else? Let's say C++ or even Java, Voltage Modular, this developer kit or what it is called. They use Java, I know, I think. So what is the difference? Let's say from the view of a programmer.
Yeah, so if you think of C++, in C++ you can do whatever you want. You can code like everything, right? But at the same time, like all that power, it comes at a cost. That some things that are easy to do, you need to create like a lot of boilerplate. If you think I want to code a DSP, like a DSP engine for my DST instrument, and what happens is that if you're a C++ programmer, you want to make your code as reusable as possible. So probably you start creating, you need to create a class, a class, C++ class, and then you add methods, and then and you want to do this code as reusable as possible. And because you're trying to make it reusable, you need to do everything in this way that requires, or at least for me, it requires a lot of boilerplate. If you want to achieve later good reusability. And with Vult, I started a different approach. So I wanted to be very easy to capture the numeric computations that I needed. And at the same time, I eliminated a lot of things that C++ allows you to do in order to simplify the coding and also minimize the number of errors that I will have. So it is basically a little bit more strict in the types as C++. And it also has a few nice features that makes it easy to write code. Let me try to think a good example. So when you make a filter, when you code a filter in C++, and you want to make it reusable, you will make a class. And then if you need two of those, you create two instances of your filter, and there is a syntax that you need to follow to like using new or something, create your object, plug your object, delete your object. And in the Vult language, it's a little bit simplified because these entities, these small blocks, are simply a function. So I create a function that does the processing, does the calculation. And if I want to create one filter, I just call that function into my bigger block. If I need a second one, I call the function again.
Okay, I see.
And I have a new instance. So I don't need to bother with creating the object or instantiating the object, connecting the things. So it's just like, or at least for me, that's the most simplest way, like a very simple way to do it. And if I compare code that is DSP code that is written in C++, let's say that you may end up with files that are hundreds and hundreds of lines. But if you compare it to the Vult, to the equivalent thing in the Vult language, is much shorter the code.
I see.
And I would say that much easier to read.
Okay. Are there somewhere courses, lessons in using Vult, or are there going to be?
I have a few videos on my YouTube channel where I show in different ways my approach to build modules. I think I have like two main series. One that was coding modules for VCV Rack, and other series that was more focused on the analog modeling. And in those two, I use the Vult language, and I show my setup. And I have in the website, a few small tutorials as well.
Okay.
So, but I'm trying to create more documents, because there are a lot of nice features that I have developed lately, and I use on my own modules, but I don't have them documented. So,
so what about creating an ebook, or at least a PDF, a large PDF course working with Vult, and sell it as an ebook? I can imagine that would be very interesting.
Yeah, it would be nice having writing a book.
Yeah.
But I'm a slow writer. It takes me a lot of time to write. For example, the blog posts that I make, either for Vult or for Wolfram, they take me quite a long time to write. But I definitely have the idea of remaking the Vult language website and make it much more approachable. At least having a better guide that can be a good tutorial to use it.
Great idea. What do you think, is Vult a language a complete beginner could start learning?
I mean, yes and no. The yes part, it is because the language is very simple, and if you know something like JavaScript or I mean, probably JavaScript is much more fully featured than Vult for some applications. I would say that it's very easy to start coding with it. The difficult part comes when you want to integrate your code into your application, because with the Vult language is you don't generate an executable or what it generates. It is source code that can be mainly in C++, JavaScript, or Java, or Lua. And in order to integrate it, you need to know that language.
I see. All right. You sent me some links to very interesting modules all around the matter of generative music. Do you have a certain relation to the matter of generative music?
Yes, I mean what I like about generative music, as I was mentioning before, when I'm working on something, I like to listen to music, and especially if it's a long generative piece, it's quite nice.
Yeah,
it can be very good for focusing. But in the area of making modules for generative music, as you know, that there are like lots of different techniques in order to get like these changing signals that you can use for your music. And one of the simplest ways that you can get like random voltages will be to use a sample and hold on noise. And the signal that you get out, it has certain characteristics. For example, if you use white noise, the distribution of the values that you will get is going to be as well. It's not going to be a normal distribution. So at some point I started thinking that, okay, that's not the only way that we can get signals, right? There are many different ways or many different algorithms that we can use to generate these waves. And probably one of them first that I made, it was Caudal, one of the modules that I have for VCV Rack and for Voltage Modular. And that one, it is a chaotic system. It is like a 4-segment pendulum. And when you drop that 4-segment pendulum, you start getting these very beautiful signals. And one nice characteristic that those have is that they're completely chaotic. There are not so many repetitions. So those signals have like some kind of nature, and if you use it instead of white noise, you're going to get like something different, something different out of them. And I actually have it here. This is like the hardware version that I'm working on.
The hardware version.
Yeah, it's still not yet ready. I'm finishing it, but this will be caudal in hardware.
Yeah, I use it in VCV.
And so once I developed that one, the basic algorithm was the pendulum. So how a composition would sound using these 4 pendulums. That's what I was thinking, and then I extended it with other algorithms. For example, this 4-planet that I added this algorithm that simulates 4 planets being affected by the gravity, and it is basically like a small universe with these 4 planets, and they are affecting each other, and then you get like again these chaotic signals that are different from what the pendulum produces. And I also added into that one a fish tank simulation.
Yes.
I was thinking, okay, let's say that I have these 4 fish, and when you see the fish, they are moving around, and I wanted to replicate that, so I made a model that I thought that will behave like that, like the fish tank.